Hi everyone, I am Saurabh and you are watching gravitonX. Physicists have solved some of the universe's biggest mysteries, but they are not done yet. A few centuries ago, it was very tiring to travel, but this has been solved by vehicles and aeroplanes. Lamps have been replaced by light bulbs and tube lights. Letters and emails have been replaced by some social media apps. Man has reached to the space, and now we are talking about colonization of Mars. In terms of technology, we are way ahead in time. We have discovered from small particles like quark to large black holes, and yet physicists today are the first to admit that they don't have all the answers. Dr. Daniel Whiteson, the co-author of the book We Have No Idea, A Guide to the Unknown Universe, said there are basic facts about the universe that we are ignorant of. I therefore have compiled such unanswered questions in physics, which I am going to cover in 5 parts. So without wasting any time, let's get started. We know about atom, that atom is something of which matter is made up, and these atoms are made up of protons, neutrons and electrons. And we know that protons and neutrons are made up of smaller particles known as quarks. Don't know about quarks? No worries, I am here. In simple terms, a quark is a type of elementary particle and a fundamental constituent of matter. Quarks combine to form particles called hadrons, and the most stable are protons and neutrons, the components of atomic nuclei. We do have something called the Standard Model of Particle Physics, which explains interactions between subatomic particles. It has also been used to predict the existence of previously unknown particles. The last particle to be found this way was the Higgs boson, which Large Hadron Collider researchers discovered in 2012. But there is a drawback. It doesn't explain why the Higgs boson exists. It doesn't explain in detail why the Higgs boson has the mass that it does. Dr. Don Lincoln, a particle physicist at Fermi National Accelerator Laboratory or Fermilab, says that the Higgs turned out to be less massive than predicted. Theory had held that it would be about a quadrillion times heavier than it is. The mysteries don't end here. We know that atoms are electrically neutral. The positive charge of proton cancels out the negative charge of electron. But how does an atom know that it has to be electrically neutral? Why do an atom has same number of electrons and protons? And there are several such questions which are still unanswered. If you know what is science, you definitely know the story of apple falling on Newton, and therefore you are familiar to the term gravity. Our feet are on the ground because of gravity. Planets revolve around the sun, it's because of gravity. Moons revolve around their respective planets, it's because of gravity. Atmosphere on the earth is also because of gravity, and the list goes on. But my point of introducing gravity is that gravity is trillion times weaker than the other 3 known fundamental forces, that is electromagnetism and the 2 kinds of nuclear forces. One of the possible reasons physicists came to know about is that in addition to these 3 dimensions of space, there might be some other hidden extra dimensions, perhaps curled up in a way that makes them impossible to detect. Physicists are not sure, but if these extra dimensions exist, and if gravity is leaking into them, it could explain why gravity seems so weak to us. Mathematicians could help in this complexity. Dr. Daniel Whiteson says that it could be that gravity is as strong as these other forces, but that it gets rapidly diluted by spilling out into these other invisible dimensions. Some hoped that experiments at the Large Hadron Collider would give a hint of these extra dimensions, but so far we are not lucky enough to discover them. And gravity is still a mystery for us. Big Bang Theory tells us how our universe came into existence. It says that the universe as we know is started with an infinitely hot and dense single point that inflated and stretched, first at unimaginable speeds and then at a more measurable rate over the next 13.8 billion years to the still expanding cosmos that we know today. An important question arises, but what came before the Big Bang? Glenn Starkman, a physicist at Case Western Reserve University says, "We say that the question is meaningless. The idea is this: if time itself began with the Big Bang, then it makes no sense to ask what came before." But hardly anyone finds this answer satisfying. The inflation model. It says that when the universe was formed because of Big Bang, its size increased again and again before slowing down to its normal rate of expansion. Some also thinks that time didn't begin with the Big Bang, but somehow emerged when the universe reached a certain level of complexity. Others say that the universe runs in cycles in an endless series of expansions and contractions. If this cyclic model is right, the Big Bang wasn't the beginning, but just a transition from an earlier era. We now have to build an enormous gravity wave detector in space so that we could detect gravitational waves created by the Big Bang to have some idea about the beginning and before the beginning. That's all for today. The next video will be released very soon. Till then, wishing you all the good luck. Thank you so much.